Hello, students. This is Saxon Algebra 2, lesson 89.A, conjunctions. In grammar, conjunctions are words like and but. In algebra, a conjunction is a situation in which there are two or more expressions that bracket the solution set. Algebraic conjunctions use the word and. So if we look at this example that I made, I will show you what's going on. On this side of the number line, we have x greater than -1. And over here, we have x less than 2. I'm sorry, we have a solid circle. We have x less than or equal to 2. Now, the thing is, this can be flipped around, and as long as the small part of the less than sign is, of the greater than sign is pointing to the same number, we can say -1 is less than x. And of course, over here we have x is less than or equal to 2. So we can put these both together like this: -1 less than x, which is less than or equal to 2. And that you can always do this kind of expression when you have a conjunction. All right, let's look at example 1. Example 1 says to graph. We are going to be graphing conjunctions, Peter. Graph -x minus 3 less than or equal to 2 and x minus 2 is less than 1. The domain is the set of real numbers. Now, I changed it to the set of real numbers. In your text, they use the set of integers. And so if you want to see what that graph looks like, they obtained it in the same way that I'm going to obtain this graph. And so I'm not going to do it twice. So you have that. So the first step is to solve for x. And so you have here with this part of the conjunction, we're going to solve x minus 3 less than or equal to 2. And I can add 3 to both sides without changing the inequality. So I have -x less than or equal to 5, but I don't want -x. I want positive x. So I need to multiply this whole thing by -1. And when you multiply -x by -1, then you get x. And when you multiply an inequality by a -1, it flips it. So now I have x greater than or equal to, and then I'm going to multiply 5 by -1, -5, x greater than or equal to -5. When we do the next one, x minus 2 less than 1, I can add to both sides without changing the direction of the inequality. So I've got x, I added 2 to both sides, x is less than 3. So just like we did before, as long as this inequality is pointing to the right numbers, I can turn it around. I won't say flip it around. We'll use flipping for multiplying by -1. But I can turn it in a different direction and say -5 less than or equal to x. Because over here, -5 is less than or equal to x. And again, we have x less than 3. So we're able to put together that conjunction as one expression: -5 less than or equal to x, which is less than 3. And so here's a number line that I've prepared. It's time to graph it because that's what the problem asked us to do. -5 less than or equal to, so that's a closed circle, and x less than 3, that's an open circle. And I can just make the whole line in between solid to show that conjunction. X is greater than or equal to -5 and x is less than -3. So you need to look in your book because in your book, the domain was the set of integers, and you can see what the same graph looks like using the dots. So to recap, conjunctions in algebra are 2 or more expressions. So here's our 2 expressions that define the solution set. The expressions are connected by the grammatical conjunction, and the graph on a number line should look like a single line segment or a single row of dots. So I hope this helped you to understand the concept of conjunctions. Please do the practice problem that has to do with a conjunction, and we'll cover the rest of, I'll make a video about disjunctions, and then we're going to finish covering lesson 89, I think next Wednesday. All right, see you in the next video.